The fundamental theorem of algebra sounds like a really big deal. It's actually not that big of a deal at all. You would think fundamental theorem of algebra, that like the word fundamental means this is the most important theorem in algebra, but it's kind of not. It's pretty simple. Okay, we have y equals x squared minus 25. The fundamental theorem of algebra says that because this is a 2, we are going to have 2 roots. A root is just an answer. It says that if the degree of the polynomial is 3, we would have 3 roots. And it says that if the degree of the polynomial is 4, it means we're going to have 7 roots. Just kidding. It means we're going to have 4 roots. Okay, so what the fundamental theorem of algebra says is that the degree of the polynomial determines the number of answers that you're going to have. Where are the roots? Well, the roots are where it crosses the x-axis. So this is a root, and this is a root. If I was going to write that as a polynomial, I see this is a negative 1, 1, 2, 3, 4. Okay, if I wanted to find that equation based off the roots, since this is minus 1, I would put in a plus 1. Since this is a plus 4, I would put x minus 4. So this would give us the equation, okay, based off of the roots that have these as the solutions. Let's take that a step further. This right here, negative 1, 1, 2, and 3. Okay, this has 3 answers, or it has 3 roots, which means its polynomial would be to the 3rd degree, and it would be x plus 1, x minus 1, and x minus 3. Okay, that's where those answers would come from. Now, if we look at a graph, okay, we have graphs in different places here. This one right here, this first one, okay, has 2 roots. All right, this has 2 real roots. Okay, this one over here has 2 answers, but it just happens to be the same one. So what we say is we have this has 1 double root. Basically, it's like I know if I have a quadratic, I have to have 2 answers. And what we do is we count that 1 answer twice. Okay, now this one right here doesn't cross the x-axis anywhere. So we would say that this one has 2 imaginary roots. When it's just kind of floating around, we say that it has imaginary roots. Now, imaginary roots always come in pairs. So if we knew that our roots were 3, 4, and 5i, since the imaginary roots have to come in pairs, I know that it would also have to be a minus 5i, because imaginary numbers come in pairs as plus or minus the I.